Hi everyone, this is Bharti here. So in my previous video, we have learned about linear regression, logistic regression, SVM, that is support vector machine. So in this session, let's try to learn the decision tree intuition. As we know decision tree, in this session, we will be learning about the decision tree classifiers. So this is one of the supervised machine learning algorithm. As we know, machine learning has been classified as a supervised and supervised. Wherein supervised learning, it is mainly focused wherein data tries to learn or predict through the labeled items, wherein unsupervised, it learns to learn the data through unlabeled items. And this can be used for both regression and classification. Classification in the sense wherein we have to predict the person has a diabetes or not, to predict whether the emails which we have received is a fake or not. Regression, wherein we have to find the price of the building, that is a regression. And this decision tree, it is based upon the tree-based learning method. So the goal of this decision tree is to predict the value of the target variable. But how it will predict? It is predicted by learning the simple decision rules inferred from the data features. So in this decision tree classifiers is a class capable of performing multi-class classification on the data sets. It can perform multi-class classification on the data sets. So by making the decisions, it will be cutting into a root node, then the decision node, then the leaf nodes. So these nodes are represented by the branches or edges. And either way of the following content means it will be like a decision node wherein we will be giving the condition. So these are called as a decision nodes. And whatever the output, the predicted is called as end node. So here we have a diagram. So in this we have a root node and we have a decision node and we have a leaf node. So what does it represent? So decision tree classifiers, this somewhat shows like a flowchart, and we have a node. This each node of the decision tree represents some of the decision of the data points that split into two leaf nodes. Here, for example, we can see this has been split into two. Here also we can see it is split into two. And each of this node represents the outcome of the decision, and each of the decision can also turn into the decision nodes. Each of into a decision nodes. Eventually, the different decisions will be lead to the final classification. This diagram, whatever it demonstrates, like how decision tree works. So this top node, as I said, this is called as a root node. Uh, each of the decision points, each of the decision points is called as a decision nodes also. And final decision is called as a leaf nodes. Whatever final decision we are making, that is called as a leaf node. But how do you see? How do you see that decision tree classifiers work in the sense? So it works by splitting the data into a series of a binary decisions. So here, if you can see, it has been divided as a binary like yes or no, yes or no. So this is like a binary decision. We can see. So this decision allows you to transfer down the tree based on other decision. You continue moving through the decisions. We will be continuing to move through the decision until the end of the leaf node, which will be turned into a predicted classifications. So also, in order to make a decision, we will be using something called as a Gini impurity. So this refers to the measurement of likelihood of incorrect classification of the new instance and all. So in depth, we will be learning in my upcoming videos. But for now, just try to understand what is root node, what is decision nodes, and what is the leaf node. And here we have taken one of the examples of the famous iris dataset, like how when we used this decision tree classifiers, basically how it looks when we take one of the features in it. Coming to one of the real world examples. So let's take, we have to, okay, I have to attend a party. So I have to attend a party, so I will think how to go. Whether should I go or not? If I'm going, so I will think whether I should go or not. So if I'm going, I will go. If no, it will be cancelled, and this is the end result of it. But if I'm going, then I will think where is the venue? Like whether it is near to my house or whether it is too far of my house. I will make a decision on this. So again, if it is very far, what I will do is I will take a cab. Or if it is very nearby to my home, then I will go by own vehicle. Okay, if I go, if I want to go through the cab, then again I will make making a decision like whether I should go through auto or Ola cabs, something like that. If it is a own vehicle, then I will think whether I can catch up some of my friends instead of going alone. Even they can fill up some of the petrol and all, right? So I will be thinking like, so each decision which I am making, I'm splitting the data into yes or no, whether the place is nearby to me. If the place is nearby to me, then how I will go. If place is not nearby to me, then how? What are the steps I can take? And if I want to take my own vehicle, who will be the person accompanying with? See, each thing it is. I'm making a decision, not and I'm giving the leave note. So mainly, what we can say is this is the party attending. This is the route note, and where is the venue? This own vehicle, these are the decision notes, and cab and cancel, these are the leave notes. So coming to the advantages and disadvantages, as we know, every algorithm has advantages and disadvantages as well. So before applying or implementing that algorithm, we have to know the advantages and disadvantages. So that based upon that, we can use the algorithm, whether that will be particularly suitable for our data or not. So coming to the advantages, compared to other algorithm, decision tree requires less effort of data preparation during the pre-processing. And decision tree as why? Because we don't want to normalize the data in the decision tree. Because of that, the pre-processing time will be a little less. And this does not require also scaling of the data as well. Missing values in the data also do not affect the process of building a decision tree to considerable any extent. Also, this decision tree model is very intuitive and easy explained to the technical team as well as the stakeholders. So moving on to the different disadvantages. If there is any small changes in the data, it can also cause the large change in the structure of the decision tree, causing the instability. As we know, decision tree, it is based like it is a tree model. So if there is any small, if there is any small changes in the data, also it affects the root node, decision nodes, leaf nodes, and all. For a decision tree, sometimes calculation can go far more complex compared to the other algorithm. Yes, as we are making the decision tree things, like we will be keep on making the decision. So in this, it can go far more complex compared to the other algorithms. There may be some of the time time involved in this procedures. It is high for the training the model, and decision tree is relatively expensive. The complexity of the, as I said, it is the time taken to train the model for the decision tree. It is very high. So as it is very high, it is highly expensive and it has some of the complexity as well. Lastly, decision tree algorithm is inadequate for applying regression and predicting the continuous value. So yes, as I said, it can be used both for regression and classification, but it is a little inadequate for applying a regression. We have to predict the continuous values for that. So yes, that's it for today's session. Let's all try to catch up in the next session about maths behind the decision tree classifiers. So for more videos, keep subscribing my channels and hit the bell icon button, like button as well. Thank you all.